Thank you. Thank you everyone for joining. And thank you, Michael and the CECS for this opportunity to share my research with this wonderful audience. So today I'm going to talk about my work, especially in robust machine learning. I'm part of the Department of PCE and also part of an artificial intelligence initiative. Before moving, let's talk a bit about my journey. I did my bachelor's back in India in electronics and communication engineering in 2012. And I obtained my master's and PhD in ECE from Oregon State University. I completed my PhD in 2023. In between, I have worked in industry. I have worked as system validation engineer at Texas Instruments as well as in NVIDIA for some amount of time. And starting December 2023, I'm proudly part of UCF. My research interests are broadly in machine learning, signal processing, and optimization. In machine learning, I'm more interested in weakly supervised learning and unsupervised learning problems. And in signal processing, I have interest in various factorization models like tensor factorization, non-negative matrix factorization, and also interested in compressive sensing. I've often used many novel synergistic tools, techniques between machine learning and signal processing to come up with novel learning strategies in my research. And in terms of optimization, I've worked and I'm very interested in stochastic optimization, scalable algorithm design, and also convergence characterizations. At UCF, I started in spring 2025 teaching Introduction to Neural Networks and Deep Learning course for ECE graduate students. And building my team at UCF, started with mentoring 2 master students in the spring term. And I also recruited 1 PhD student and possibly will be recruiting 1 visiting PhD student in fall 2024. And the student is about the AI Doctor Fellowship and still actively looking for more potential PhD candidates to build the team. Okay, so I know there is no need for motivating about AI nowadays, which was much different a few years back, actually. AI has penetrated many important aspects about our life. It has have huge impact in many critical applications. The key factor for the AI revolution, one of the key factors is the data, right? We need good quality data for the AI to be safely and reliably deployed in real world. But the problem is that often it's very hard to obtain the good quality data. In many critical applications, there exist a lot of uncertainties. And the problem becomes more worse when the uncertainties like the observation noise or the distribution shift or dynamic nature and everything gets entangled. So in these all aspects, robust learning is a very critical tool for deploying the AI systems or the learning systems in real world applications. So with that, I would like to give a brief talk about my past project, which is in robust learning. So during my PhD, I have worked a lot in worked with noisy data, especially the data which has a lot of noisy labels. And think about this critical applications in remote sensing or medical domain, where we have labels which is very limited. And the problem becomes very worse if the labels become so noisy. So me and my team have come up with a very novel approach in combining the factorization tools in signal processing, which is a non-negative matrix factorization, and leveraged its identifiability aspects in building a provable, robust classification for noisy data. Which has appeared in ICLR 2023. In fact, we are extending that model to some of the other aspects like the constrained clustering and so on, which has leveraged this low-rank factorization models and the deep learning to come up with provable learning frameworks. And another important work was in a robust prediction for undercounted data. For example, in ecology and epidemiology, we have this, for example, plant-pollinator interactions or COVID-19 data, which has a lot of observations, which is counts and which may be heavily undercounted. So the one of the task is to predict the unobserved entries or unobserved data points, right? So in this aspect, because of this undercounting effect, it becomes a challenging aspect. So recently we have leveraged a Poisson binomial and neural network based model with low rank tensor factorization to come up with a robust prediction for this undercounted data. And in fact, we have observed very interesting results with COVID-19 data. We have extracted the detection probabilities for different counties in terms of the COVID-19, and also found the correlations with respect to the testing capacities of these counties. So this work was appeared in ICML 2023. And now let me talk about my ongoing efforts with robust machine learning and also other collaborations here at UCF. So right now I'm working towards coming up with an efficient instance-specific modeling for data uncertainties. This aspect is actually can be quite useful in terms of multi-level classification or fair classification or semi-supervised learning. Here, if we can model this data uncertainties in an instance-specific way, it is very useful, but the problem becomes very challenging in terms of a learning problem as well as model identifiability. We want to learn two nonlinear functions and disentangle them. So coming up with a provable approach for this can be actually beneficial for different applications, as I mentioned. So in this project, I'm looking for how to effectively mitigate this instant-dependent data uncertainties. Another project that I'm looking at is robust deep active learning. Active learning is a traditional paradigm which has been quietly used, especially in domains where we have limited amount of data labels. So it is very critical to use the most informative labels in active learning. But the problem becomes challenging when we work with deep learning, which is very data hungry, and also becomes challenging when we work with the noisy labels. So here, my idea is to come up with novel noise-aware metrics and also noise modeling strategies, and also characterizing the annotator skills and coming with an algorithm design for this particular framework. So the questions again, how can we probably enhance this deep active learning with some noise awareness? Another problem that I'm currently looking along with some of my colleagues at ECE and CS is how can we leverage domain knowledge to build robust learning systems? Because when I talk to different practitioners across different domains, people are sometimes reluctant to use AI learning frameworks because there exists very rich domain knowledge. And sometimes it's very hard to combine this domain knowledge, especially in the presence of a lot of uncertainties in the real world data. So here in this project, we are looking to build an informed automated decision-making system for distribution system model validation under various data uncertainties present in the real world. Okay, so that being said, my goal here in my research goal is to contribute toward the use of AI in more responsible ways. Right now, I'm focusing on robust AI systems with various problems in robust learning. And I'm also very much interested in computationally efficient AI systems, building parsimonious DNN modeling, leveraging low-rank factorization tools, and also building stochastic algorithm design. I'm very much interested and curious to see all these methods, how do they work and how can they work in the real world, and looking for strong application areas in which has some social impact. So for that, I'm actively looking for funding and collaboration opportunities. With this, I would like to conclude my talk. Thank you, everyone. And if you have any questions, I'm happy to answer.